We are going to talk about complex zeros and the fundamental theorem of algebra. Alright, so the fundamental theorem of algebra says a polynomial function of degree n has n complex zeros, both real and non-real. Some of these zeros may be repeated. We talked about multiplicity earlier. Okay, so I'm so sorry, my husband is snoring. So if, for example, I had a function that was like x to the 5th plus 3x to the 7th, so on and so forth, the highest degree is 7. That tells me that for sure this thing has 7 complex zeros. Complex means you can write it in the form a plus bi. And even if you have, even if the thing crossed at positive 3, let's say, okay, you can write 3 as a complex number. You'd write it as 3 plus 0i. Okay, so be careful. Complex just means that you can write it in this form, and you can write even whole numbers in that form. Real, now of course if it's written in this form and it really does have an I in it, then it's not real. Okay, so you have real and non-real ones. This one would be real. Something like 2 minus 7i would obviously be imaginary. Alright, we also have the linear factorization theorem, which says if f of x is a polynomial function of degree n greater than 0, then f of x has precisely n linear factors, and the function can be factored into some leading coefficient times each of the factors. Again, a would be the leading coefficient, and the z1, z2, zn are the complex zeros of f of x. The zi, in other words, the z sub whatevers, are not necessarily distinct numbers. Some may be repeated. Again, you have multiplicities. All right, the fundamental polynomial connections in the complex case says the following statements about a polynomial function f are equivalent if k is a complex number. X equals k is a solution or a root of the equation f of x equals 0, meaning if you take whatever function you have, let's keep it simple, let's say x squared plus 3x minus 4, okay? If you found a solution to this, again, when you set the function equal to 0 and solve it, we could factor, this would be x plus 4, x minus 1. Okay, so we would have x equals negative 4, x equals 1. So what it says is that if k is a complex number and x equals k is a solution, if it's a solution or root of the equation, f of x equals 0. Okay, we also know then that k is a 0. We would say that negative 4 is a 0 of this function. Positive 1 is a 0 of this function. And x minus k, meaning these two, x plus 4 and x minus 1, are both factors. Okay, so again, I can say x equals negative 4, x equals 1. That's what this says. I can say that negative 4 and 1 are zeros. And I can say that x plus 4 and x minus 1 are factors of the function. Okay. So what we're going to, complex conjugate zeros theorem says, suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers with b not equal to 0, and a plus bi is a 0 of the function, then its complex conjugate, a minus bi, is also 0. So if I give you a function, let's say x squared plus 3x plus 2, and I tell you that 3 plus 2i is a 0, then this theorem guarantees that its conjugate is also a 0. Has to be. This theorem guarantees it, which is kind of happy birthday, Merry Christmas to us. I mean, if we're trying to find all of the zeros, okay, and they give me a complex one, then I know that its complex conjugate is also 0. Okay, the factors of a polynomial with real coefficient. Every polynomial function with real coefficients can be written as a product of linear factors and irreducible quadratic factors, each with real coefficients. For example, my other one on the back, well, my x squared plus 3x minus 4, that factored into x plus 4 times x minus 1. What this says is sometimes you get down to, let's say you factor something and you get these factors, x plus 1, x minus 7, and x squared plus 1. This isn't linear, this is second degree, and when they say they want linear factorization, they want all these first degree ones. Well, you can't factor this quadratic. You could solve it, you could do quadratic formula and figure out what x equals, but you can't factor this. There's no way to factor sum of cubes. Okay, so we would say that here is its factorization written as a product of its linear factors and irreducible quadratic factors. The only thing you could do would be to solve this, and then you could write it as, because this factors into plus or minus I, so it'd be x plus I and x minus I. But again, those are imaginary. Okay? Alright, and a polynomial function of odd degree, it says every polynomial function of odd degree with real coefficients has at least one real zero. And that's because if you are an odd function, one tail has to point down and one tail has to point up. Well, the only way that's going to happen is you got to cross that x-axis at least one time. Okay, because that, even if somebody was trying to be creative and they said, no, look, put it right here and connect it. Okay, but this arrow points up. It's still going to eventually cross the x-axis. Even degrees, not necessarily. Okay, that would be an even function that never crosses the x-axis. But if it's odd, it has to cross at least once. Okay? Alright, so it says, write the polynomial function in standard form and identify the zeros of the function and the x-intercepts of its graph. Okay, before I write it in standard form, I'm going to answer the last two questions first. To identify the zeros, you set the factors equal to 0. So x minus 5 equals 0, x minus the square root of 2i equals 0, and x plus the square root of 2i equals 0. And you solve. Plus 5, x equals 5 is a 0. Add the square root of 2i, add the square root of 2i, x equals the square root of 2i. Subtract the square root of 2i, subtract the square root of 2i, x equals the negative square root of 2i. So, what are my zeros? Also known as my x-intercepts. They're the same thing. Are 5, the square root of 2i, and the negative square root of 2i. So there's the last part of the question. Now, to write it in standard form, we simply multiply these out. Now, we're allowed to multiply in any order we want to. I'm going to do these imaginary ones with the radicals because I noticed that they are conjugates, thanks to the complex conjugate theorem. And I know that if I multiply those first, I'm going to eliminate those radicals and the i's. So I'm going to do these two first and save this for last. X times x is x squared. X times a positive square root of 2i is a positive x square roots of 2i. A negative square root of 2ix is a negative square root of 2i, I mean x times an x. Oh, sorry. Hope you guys don't mind snoring. Minus x square roots of 2i. And the last one is going to be a negative square root of 4i squared. So we can combine like terms in the middle and replace I squared on the end. But because these were conjugates, these are going to cancel. This is going to turn into 2, and this is going to turn into negative 1. So altogether I have x squared minus a 2 times a negative 1. That's going to give me x squared plus 2. Yes? And then I have to bring down my x minus 5. And I'm going to distribute that. So I have x times x squared is x cubed, x times 2 is 2x, negative 5 times x squared is negative 5x squared, negative 5 times 2 is negative 10. Put it in the right order, and my function in standard form is going to be x cubed minus 5x squared plus 2x minus 10. There's my function, there's my zeros, there's my intercepts. Okay, and if you can see, it crosses at 5. That one's real, and these two are imaginary. It doesn't cross the x-axis. Alright, so let's try another one. Again, you can multiply in any order you want to. I'm going to do these two first because these two are conjugates. And conjugates always make math easier and gets rid of things. But they do want the zeros and the x-intercepts, and those are the same thing. So for my zeros and x-intercepts, you set each factor to 0. So x minus 3 equals 0, x minus 3 equals 0, x minus I equals 0, x plus I equals 0, and you get x alone. So add 3, x equals 3, add 3, x equals 3, add I, x equals I, minus I, x equals negative I. So my zeros are 3, I, negative I. Or we could say 3 multiplicity 2. Remember, that means there's going to be tangent there. Okay? Alright, so I'm going to do my conjugates first. I'm going to have x times x is x squared. X times I is positive ix. Negative I times x is negative ix. Negative I times positive I is negative I squared. Combine terms in the middle, replace I squared on the end. Those cancel. I have x squared minus a negative 1. Distribute, and I get x squared plus 1. And then I'm going to go ahead and multiply these two together. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Combine like terms, and I get x squared minus 6x plus 9. And I'm going to multiply these two together now, and I'll be done. So x squared times x squared is x to the 4th. X squared times 1 is x squared. Negative 6x, negative 6x times x squared is negative 6x cubed. Negative 6x times positive 1 is negative 6x. And positive 9 times x squared is positive 9x squared. Positive 9 times 1 is positive 9. Combine like terms. I have x to the 4th, no other cubes, minus 6x cubed, x squared, and 9x squared is positive 10x squared. X is all alone, drop it, and my constant is all alone, drop it. And my function in standard form is x to the 4th minus 6x cubed plus 10x squared minus 6x plus 9. My zeros and my x-intercepts are positive 3, I, and negative I. And if you can see the graph, the only place it touches is at positive 3, and it's a multiplicity of 2, so see how it's tangent? It just touches and turns. It doesn't actually pass through. Alright, this one, they're just getting longer, okay? You can multiply in any order you want. I see the conjugates first. Sorry, and I'm going backwards. I'm going to do my zeros and my x-intercepts. Alright, I'm going to have x equals 0, x minus 2 equals 0, x plus 4 equals 0, x plus 3 minus I equals 0. Sorry. X plus 3 plus I equals 0. So, this one's already done. X is 0. Add 2, x equals 2. Minus 4, x equals negative 4. I need more room than that. 0, 2, negative 4. This one I'm going to minus 3, but I also have to add I and add I, which is going to give me x equals negative 3 plus I. Okay, this one I'm going to have to minus 3, minus 3, minus I, minus I. That's going to give me x equals negative 3 minus I. Alright, so notice that we have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 factors. And zeros and x-intercepts are the same thing. Okay, so now we can put all these, multiply all these together. I'm going to start with the conjugates. So this one's going to get a little long. X times x is x squared. X times 3 is 3x. X times I is ix. Okay, and I'm going to try and use some color. Switch color next term going. 3 times x is 3x. 3 times 3 is 9. 3 times I is 3i. Oh my gosh, I'm so sorry about the snoring. Negative I times x is negative ix. Negative I times positive 3 is negative 3i. Negative I times positive I is negative I squared. Now, the I, everything with an I in it should cancel out, or we did something wrong, and the I squared on the end will turn into a real negative 1. And if I look, there's a positive ix, there better be a negative ix, there it is, they cancel. There's a positive 3i, so I know there's got to be a negative 3i, they cancel. And this I squared is going to turn into a negative 1. So now I have x squared plus 3x plus 3x plus 9 minus negative 1. Distribute x squared plus 6x plus 9 plus 1. Combine like terms one last time, and I have x squared plus 6x. Sorry, my pen goes a little nuts sometimes. Plus 10. These two are done. Now I'm going to do these two next. X times x is x squared. X times 4 is 4x. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Combine like terms, that's x squared plus 2x minus 8. Then I'm going to bring down this x and distribute it, and that's going to give me x cubed plus 2x squared minus 8x. Alright, and now I'm going to distribute all of this out. So I'm going to have x cubed times x squared, which is x to the 5th. X cubed times 6x is positive 6x to the 4th. X cubed times 10 is 10x cubed. And then let's see what color next. How about blue? 2x squared goes times x squared is 2x to the 4th. 2x squared times 6x is 12x cubed. 2x squared times 10 is 10x squared. And then my negative 8x goes times x squared is negative 8x squared. Negative 8x times positive 6x is negative 48x. Negative 8x times positive 10 is negative 80x. Alright, then we have to combine like terms. My husband. I don't see any other 5th degree, so it drops. There's a 4th degree, a 4th degree, so that makes 8x to the 4th. I've got a 3rd degree, a 3rd degree, that makes positive 22x cubed. A 2nd degree, that makes positive 2x squared. Negative 48x and negative 80x. Negative 48, or 128, right? I just get nervous when I'm doing it on camera. Negative 128x. There's my function in standard form. There's my function. There are my zeros and x-intercepts. Yes? Alright, you try this one, hit pause, come back when you're ready. Hopefully you got number 4. If not, let's look at y. X times x is x squared. X times positive 5i is positive 5xi. Negative 5i times x is negative 5xi. Negative 5i times positive 5i is negative 25i squared. These are conjugates to each other, so I know these two are going to cancel. And I squared on the end turns into a real negative 1. And I am going to distribute, and I get x squared plus 25. There's my function in standard form. Go back up to here to get its zeros, and you take the factors and set them to 0. Add 5i, x equals 5i. Minus 5i, x equals negative 5i. So my function is x squared plus 25, and my zeros are plus or minus 5i. Alright, try this one. Hit pause, come back when you're ready. And I hope you got 2. If not, let's look at y. Again, I'm going to start with my zeros. So this says x equals 0, this says x plus 3 equals 0, x plus 2 minus I equals 0, x plus 2 plus I equals 0. This one's done. Minus 3, x equals negative 3. Minus 2, add I, x equals negative 2 plus I. Minus 2, minus I, and x equals negative 2 minus I. Okay, so those are my zeros. And actually, if you look, the only ones that have the right complex numbers are, oh no, these would be right too. Yeah. But I also have, these have the right, see how these twos are positive, so those are out. Those are out. And then this one has the negative 3, but it doesn't have the 0, so that one doesn't have enough, right? There's the negative 3 and the 0, so that one has to be my function. But to get the practice of multiplying all these out, again, I'm going to start with my conjugates. So I have x times x is x squared, x times 2 is 2x, x times I is ix, 2 times x is 2x, 2 times 2 is 4, 2 times I is 2i, negative I times x is negative xi, negative I times 2 is negative 2i, negative I times positive I is negative I squared. Alright, the I, anything with an I in it should cancel, and the I squared on the end will be a negative 1. So they've got a positive ix and a negative ix. I mean, they're written backwards, but it's the product of the same two numbers, so they're the same. A positive 2i and a negative 2i. So I've got x squared plus 4x plus 4 minus a negative 1. The double negative turns positive, combine the 4 and the 1, and I get x squared plus 4x plus 5. Then I've got to multiply by the other two, so I'm going to multiply them together first. That gives me x squared plus 3x. Now I can multiply those two together. X squared times x squared is x to the 4th. X squared times 4x is positive 4x cubed. X squared times 5 is 5x squared. 3x times x squared is 3x cubed. 3x times 4x is 12x squared. 3x times 5 is 15x. Alright, then I'm going to combine like terms. I get x to the 4th. 4x cubed plus 3x cubed is 7x cubed. 5x squared plus 12x squared is 17x squared. 15x is all alone. And there is my function. Okay? Alright, so what does the degree of the polynomial function tell you about the number of complex zero and linear factors? The highest degree, n, is the number of complex zeros and linear factors. Okay, now it doesn't mean they're all going to be real and cross the x-axis that many times, but if the degree is 5, there's 5 solutions. If the degree is 7, there's 7 solutions. Okay, and how do you write a polynomial function given its zeros? Turn its zeros, write zeros as factors, and multiply together and simplify. Alright? Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include. So we're just absolutely going all the way now from before they said f of x equals x minus such, x minus such, da 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 da, and we multiply them together. We just have one extra step to do before we can do that. Okay, and here's what it is. They're telling me the zeros, so we're starting all the way at the bottom. And this says that x equals -3, and x equals 4, and x equals 2 minus I. And it doesn't say it, but the complex conjugate theorem says then because I've got a complex, then its complex conjugate, which would be 2 plus I, is also a 0. Okay? Alright, so now I have my zeros, which I need to write them as my factors. Well, you won't write this out every time, but to write them as factors, you want 0 back on this side. So this says x plus 3 equals 0, minus 4 minus 4, x minus 4 equals 0, minus 2 plus I gives me x minus 2 plus I equals 0. Minus 2 minus I gives me x minus 2 minus I equals 0. And now I can write my function is going to be all those factors multiplied together. So x plus 3 times x minus 4 times x minus 2 plus I times x minus 2 minus I. And now we're right back to the first half of the class where they gave us this to start with. I just had this extra step now. I had to write my own factors from the zeros. But now we're doing the same thing that we did. Again, I see conjugates, so I'm going after them first. So I got x times x is x squared. X times -2 is -2x. X times -I is -ix, or xi, doesn't matter how you write it. -2 times x is -2x. -2 times -2 is positive 4. -2 times -I is positive 2i. Positive I times x is positive ix. Positive I times -2 is -2i. Positive I times -I is -I squared. Now we can combine like terms. The i's should all cancel. There's a positive ix and a negative ix. There's a positive 2i and a negative 2i. And I squared is going to turn into a real -1. So now if I combine like terms, I have x squared minus 4x plus 4 minus a -1. Distribute the negative, and that's going to be a positive. Combine 4 and 1, and I have x squared minus 4x plus 5. And then my two purples that are still back up there, I'm going to multiply them together before I drop them times this one. So x times x is x squared. X times -4 is -4x. Positive 3 times x is positive 3x. Positive 3 times -4 is -12. Combine like terms. and I have x squared minus x minus 12. So now, red and green Christmas. If I multiply those together, I will have my function. So x squared times x squared is x to the 4th. X squared times negative 4x is negative 4x cubed. X squared times positive 5 is 5x squared. Negative x times x squared is negative x cubed. Negative x times negative 4x is positive 4x squared. Negative x times 5 is negative 5x. And I wonder why I don't sleep at night. Negative 12 times x squared is negative 12x squared. Negative 12 times negative 4x is positive 48x. Negative 12 times positive 5 is negative 60. Alright, and combine like terms. No more x to the 4th. There's a cube and a cube. Negative 4, negative 1 makes negative 5. There's a square and a square and a square. 5 and 4 is 9. Minus 12 is negative 3. X squared. I have a linear x and a linear x. Negative 5 plus 48 is positive 43x. And the minus 60 drops. And there is my function. Oops. There is my function in standard form. Yeah? Has to be a 4th degree function because there's 1, 2, 3, and 4 because its conjugate is also a 0. Alright, so it says write a polynomial function of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus I. Well, darn it. Now I've got 2 complex. So I have 2 other zeros. I also have x equals 1 minus 2i, and I also have x equals 1 plus I. So if I write my function out, I'm going to have x minus 1 times x minus 1. I'm going to do this step in my head, minus 1, minus 1. This one is going to be minus 1 minus 2i, so x minus 1 minus 2i. And then I'm going to put its conjugate next to it, which is going to be minus 1 plus 2i. X minus 1 plus 2i. Everybody understand that I'm doing that to both sides? Minus 1 minus 2i, minus 1 plus 2i, yes. And then I'm going to do this one, which minus them over is going to be x minus 1 plus I. And then this one's going to be x minus 1 minus I. This one is going to be a pain in the rear end to multiply out. I'm just going to start at the last 2 conjugates. So x times x is x squared. X times negative 1 is negative x. X times negative I is negative ix. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative I is positive I. I times x is positive ix. I times negative 1 is negative I. I times negative I is negative I squared. Combine like terms. I have an x squared. This negative ix cancels the positive ix. This positive I cancels the negative I, and that's going to turn into a negative 1. So I have x squared minus x, and minus x is minus 2x. A positive 1 and a positive 1 is going to make a positive 2. Okay, I hope I did that in my head there a little bit. That's going to be a minus negative 1 because the I squared turns into that. Then distribute the negative is positive 1. Combined with that positive 1 is positive 2. These two are done. So now, and I saved some space by doing a couple steps at once. I hope I didn't lose you. Alright, so now let's do these 2 conjugates. X times x is x squared. X times negative 1 is negative x. X times 2i is positive 2xi. Negative I goes. times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times 2i is positive 2i. I'm writing too big, aren't I? Darn it. Negative 2i times x is negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is negative 4i squared. Okay, combine like terms. I've got an x squared. Positive 2xi and a negative 2xi cancel. A positive 2i and a negative 2i cancel. And this I squared turns into a negative 1. So I have x squared minus x is minus 2x. This is going to be minus 4 times a negative 1 is going to be positive 4. And a positive 1 makes a positive 5. These two are done. And then if I do the last two purples at the front, x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Combine like terms, I get x squared minus 2x plus 1. Now I have to multiply all of those together. You see how long it's going to get? Because now we've got 3 trinomials. And this will be as bad as it gets, guys. So now at this point, they're all just as wicked, so I just go left to right. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times positive 5 is 5x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is positive 4x squared. Negative 2x times positive 5 is negative 10x. And positive 1 times x squared is positive x squared. Positive 1 times negative 2x is negative 2x. Positive 1 times positive 5 is positive 5. Combine like terms. There's no other 4th degree. I've got a 3rd degree and a 3rd degree. Negative 2x cubed, negative 2x cubed is negative 4x cubed. A 2nd degree, a 2nd degree, a 2nd degree. 5 plus 4 is 9, plus 1 is 10. Negative 10x, negative 2x is negative 12x, plus 5 comes down. But I still have to multiply by this guy. So there we got x squared minus 2x plus 2. Oops. Okay, so now if we distribute, I have x to the 4th times x squared is x to the 6th. X to the 4th times negative 2x is negative 2x to the 5th. X to the 4th times 2 is 2x to the 4th. Next, oh my gosh, negative 4x cubed times x squared is negative 4x to the 5th. Negative 4x cubed times negative 2x is negative 8x to the 4th. Negative 4x cubed times positive 2 is negative 8x cubed. Positive 10x squared times x squared is positive. Oh, I shouldn't use green. Let me change that. How about a light blue? 10x squared times x squared is positive 10x to the 4th. Hold on, my hand's asleep. 10x squared times negative 2x is negative 20x cubed. 10x squared times positive 2 is positive 20x squared. Well, negative 12x times x squared is negative 12x cubed. Negative 12x times negative 2x is positive 24x squared. Negative 12x times positive 2 is negative 24x. Oh my goodness, one more. Positive 5 times x squared is positive 5x squared. Positive 5 times negative 2x is negative 10x. Positive 5 times positive 2 is positive 10. And we can now combine like terms. Well, let's see. We've got x to the 6th. No more. 2x to the negative 2x to the fifth. And a fifth. No more fifths. So negative 2 minus 4 is negative 6x to the fifth. We have a fourth degree, a fourth degree, a fourth degree, and that's it. So we have 2 minus 8 is negative 6. Negative 6 plus 10 is positive 4. We have a third degree, a third degree, a third degree. Sorry. Where were my third degrees? So we've got negative 8, negative 20 is negative 28, negative 12 makes negative 40, x cubes. I got a square, and a square. 20 plus 24 is 44. 44 plus 5 is 49, x squared. And I've got a linear and a linear. Negative 24 minus 10 is negative 34x. Oh, this keeps going forward. And minus 10. There is my function. Phew. Oh, alright, you tried this one. Hit pause, come back when you're ready. And I hope you got one. Alright, this says that my function will be x minus 5, x plus 3, x plus 1 minus 4i. Again, I did that without doing any of the work, but if I lost you, when they give me zeros, they're telling me what x equals. So they're telling me x equals 5, x equals negative 3, x equals negative 1 plus 4i, which tells me that there's another one that says x equals negative 1 minus 4i. Anytime you have an I, alright, you've got another one, which is going to give me x plus 1 plus 4i. And the way you go from there to my factors, you get 0 back on one side. X minus 5 equals 0. There's one of my factors. Add 3, I get x plus 3 equals 0. Add 1, and subtract 4i, and I get x plus 1 minus 4i. Add 1, add 4i, add 4i, you get x plus 1 plus 4i. So there's all four of my factors. To get into polynomial form, you multiply them out. I'm going to start with my conjugates first. X times x is x squared. X times 1 is 1x. X times 4i is 4xi. Positive 1 times x is positive x. 1 times 1 is 1. 1 times 4i is 4i. I don't know if my shirt keeps hitting this or what. I apologize though. Another color, right? So then I have negative 4i times x would be negative 4xi. Negative 4i times 1 is negative 4i. Negative 4i times positive 4i is negative 16i squared. So if we clean that up, I'm going to have x squared, this 4xi and this negative 4xi cancel, this positive 4i, this negative 4i cancels, and that's going to be negative 16 times negative 1. So I have x squared plus x is plus 2x, plus 1 plus 16 is plus 17. Alright, then I'm going to multiply the two brown ones together at the front. Alright, so I have x times x is x squared. X times 3 is 3x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. combine like terms, and I get x squared minus 2x minus 15. And now multiply your trinomials together and we will be done. X squared times x squared is x to the 4th, times 2x is 2x cubed, times 17 is 17x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times positive 2x is negative 4x squared. Negative 2x times 17 is negative 34x. And 15. Negative 15 times x squared is negative 15x squared. Negative 15 times 2x is negative 30x. And negative 15 times positive 17 is negative 255. So now if I combine like terms, I have x to the 4th. There's a cube, there's a cube. 2, take away 2, cancels. There's a square, there's a square, there's a square. 17 minus 4 would be 13 minus 34 is negative 21x squared. I have a first degree and a first degree. Wait. No. I'm sorry. 17 minus 4 is 13, not 34. I need to do 15. 13 minus 15 is negative 2. Right? Yeah, negative 2x squared. Sorry. Then I have my linears. Negative 34x, negative 30x is negative 64x. And then my minus 255. Okay? And there's my function. Alright, hold on just a second. Alright. Plugged in. Alright. It says, write a polynomial function of minimum degree in standard form with real coefficients whose zeros and their multiplicities include those listed. So this says x equals 2 and x equals 2 because it says it's a multiplicity of 2. This says that x equals 3 plus I, but because of the conjugate theorem it also means that x equals 3 minus I. So if we write our function, factors first. So minus 2, x minus 2 equals 0, minus 2, x minus 2 equals 0, minus 3 minus I gives me x minus 3 minus I equals 0. Minus 3 plus I get x minus 3 plus I equals 0. So then my function is going to be all those factors multiplied together. Alright, again, I'm going to start with my conjugates. X times x is x squared, x times negative 3 is negative 3x, x times I is positive xi. Negative 3 times x is negative 3x, negative 3 times negative 3 is positive 9, negative 3 times positive I is negative 3i. Negative I times x is negative xi, negative I times negative 3 is positive 3i, negative I times positive I is negative I squared. The I should die, the I squared turns real, and combine like terms. So there's a positive xi and a negative xi, a negative 3i and a positive 3i, and that's going to be minus a negative 1, which is going to be positive 1. So combining like terms, there's my second degree. First degree makes negative 6x. Constant makes positive 10. Now I'm going to do the two purples at the front before I multiply by that trinome. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Combine like terms, and I have x squared minus 4x plus 4. There's my factors now. I went from linear factors, now I'm at quadratic factors, and then when I multiply those together, I'll be at the final quartic function. We get fourth degree. Alright, so if we distribute x squared times x squared is x to the fourth. X squared times negative 6x is negative 6x cubed. X squared times 10 is 10x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 6x is positive 24x squared. Negative 4x times positive 10 is negative 40x. And positive 4 times x squared is positive 4x squared. Positive 4 times negative 6x is negative 24x. Positive 4 times positive 10 is positive 40. Combine like terms, and I have no more fourth degree, so x to the fourth. Third degree, negative 6 minus 4 is negative 10x cubed. Second degree, second degree. 10 and 24 is 34, plus 4 is 38. First degree, negative 40 minus 24 is negative 64x. And the positive 40 comes down. And there, my friends, is our fourth degree function. Yeah? These are all linear factors. And these are quadratic factors of this function. Okay? Alright, so you try. Hit pause, come back when you're ready. Hopefully you got 2. If you did not, let's look at why. This says that x equals 1. This says that x equals 3 plus 2i, which means x also equals 3 minus 2i. Oh, multiplicity 2, so this is twice. So my function will be, again, I'm going to do this in my head, see if you follow. X minus 1, x minus 1, x minus 3 minus 2i, x minus 3 plus 2i. Again, if I lost you, look at where it came from. Minus 1, there's my x minus 1. Minus 1, there's x minus 1. Minus 3, minus 2i, there's my x minus 3 minus 2i. X minus 3 plus 2i, there's my x minus 3 plus 2i. Okay, hopefully you can get that without having to write it all down. Alright, and then I'm going to start with my conjugates. So, x times x is x squared. X times negative 3, negative 3x. X times 2i is positive 2xi. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times 2i is negative 6i. Negative 2i times x is negative 2xi. Negative 2i times 3 is positive 6i. Negative 2i times positive 2i is negative 4i squared. Cancel the i's, change the I squared, and combine like terms. Negative 6i, positive 6i, negative 2xi, positive 2xi. This turns into minus 4 times negative 1, which turns into positive 4 on the end. So, combine like terms, and I have x squared minus 3x is minus 6x. Plus 9 plus 4 is plus 13. And then I'm going to multiply the first two together. X times x is x squared, times negative 1 is negative x, negative 1 times x is negative x, negative 1 times negative 1 is positive 1. Combine like terms and I have x squared minus 2x plus 1 equals my function. Again, those are all my linear factors, and these are my quadratic factors of the function I'm trying to write. Okay, so now I'm going to multiply the two trinos together, patiently. X squared times x squared is x to the fourth. X squared times negative 6x is negative 6x cubed. X squared times 13 is positive 13x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 6x is positive 12x squared. Negative 2x times 13 is negative 26x. Positive 1 goes. Times x squared is positive x squared. Times negative 6x is negative 6x. Times positive 13 is positive 13. Combine like terms. I have a fourth degree, so x to the fourth. My function equals negative 6x cubed, negative 2x cubed is negative 8x cubed. Positive 13x squared and 12x squared is 25x squared, and one more is 26x squared. Negative 26x and negative 6x is negative 32x, and positive 13 drops on the end. And there we go. Alright, so we already talked about that. What does the complex conjugate theorem guarantee? If a plus bi is a zero of a polynomial, then its conjugate, a minus bi, is also a zero. Guaranteed. Alright. Match the polynomial function graph to the appropriate zeros and multiplicities. I can see that it crosses at negative 1, so x equals negative 1, and it has to have an odd multiplicity because it has to have an even multiplicity because it doesn't pass through, it just touches and turns. And then I can see 1, 2, 3, 4 at positive 5, x equals 5, it has to have an odd multiplicity because it actually passes through there. Okay? So I'm looking for negative 1 with an even multiplicity and 5 with an odd. That works. Nope. Negative 1, that's even, but nope. 5 has to have odd. Nope. So the answer has to be, oops, A. Alright, so same with this one. Alright. Hit pause, come back when you're ready. And I hope you got 1. If you didn't, let's look at y. This says x equals negative 2. And since it passes through, it has to have an odd multiplicity. This says that x equals 3. That has to have an even multiplicity because it touches and turns, it doesn't pass through. So the only one that says x equals 3 with an even multiplicity and x equals negative 2 with an odd multiplicity is number 1. Alright, so how do you decide how many complex and real zeros a function has? N is how many complex. And then we can use factoring and graphing to decide which ones are real. If it touches or crosses the x-axis there, then you found a 0. Then your 0 is real. Alright, it says, how can you use the graph of a function, synthetic division, and the quadratic formula to find the real and complex zeros of a quadratic? I'm going to save that for the next lesson. That's coming next. We actually haven't done that yet today. Alright, we are at homework, so we are done. Happy homeworking. And I will see you next time.